Yeah, today we'll be doing this question that appeared in Leetcode Biweekly contest 932497 maximum star sum of a graph, and the question statement given is there is an undirected graph consisting of n nodes numbered from 0 to n minus 1. You are given a zero indexed integer array values of length n where values of I denotes the value of the ith node. You are also given a 2D integer array edges where edges of I is equals to a of I and b of I, and it has been said that it is an undirected edge. And let's understand the definition of a star graph that has been given here. So they have said there is a star graph, and what does this star graph mean? So a star graph means that there will be some edges surrounding to it. That means, let's just say, if you're having well, if we just come on to here, what are the star edges that could be present here? It is one of these. Why so? Because according to their definition of star edge, it means that there could be more than one edges to it that is present there, or it could be zero also, but the graph is at the center and it is a subset of edges of the given graph such that there exists a common node for all the edges. That means if we are considering this as a start node, what can we have? Either we can have zero edges, that means let's just say we have a graph something like with only one node. That is also acceptable. Now, there could also be a graph, let's just say, wherein we have this 7 and 2. And if I just consider this 7 as my star node, okay, then what other node do I have to it? I have 2 attached to it. So if I consider now 2 as a star node, what is the other node that is attached to me? That is 7, right? So basically the starred node definition turns out to be the number of edges that are connected to some particular node. So if this is my particular node, what are the number of edges that are connected to me? This, and this. So these are the possible edges which can be a possible subset of this star node. Fine. So I hope the star node's definition is clear. And they have said the star sum is the sum of the values of all nodes present in the star graph, and we are given an integer k. We need to return the maximum star sum of a star graph containing at most k edges. So this line is very important. It is at most k, and I had mistakenly read this as at least k, which is actually wrong, but we have to consider this as at most k. Okay, and what do we mean by at most k here, right? So if we, let's just say, consider this one as our star node, fine. So what is the maximum sum that we can get if we take two edges, okay, excluding the star node? That means excluding this, we will not count this as a node here, but we are going to count its value, that is 2. We are going to count that, but we are not going to count this as one node. Okay, now it has said that you can take with you two more nodes. Now which two more nodes are you going to take? We can see that we have got three options from here: 1, 2, and 3, three options, right? And we can take at least sorry, at most two. So I see that there are values like 4, 3, and 1. And why am I writing it in sorted order? You will understand it later on while we move forward to it. So if we see that if we just take the two greatest element, then our sum will be the largest, because we can add 2 plus 4 plus 3, and which will result out to be 9, right? Which is obviously greater than 3 plus 2 plus 1, right? So this is a hint or an intuition to this question on how to do it. So now let's understand this carefully with this example, and I think it will be more clear to you after this. So if we take node 3 as a star node, now every node can be considered as a star node, right? If there are at most k edges that are present there, fine. So we can take at most k edges. Now let's just say if we are considering 3 as a star node, fine. Now what are the values that I can take, and the values that you can take or add to your sum will be only the edges part. Fine. So these are the edges, and you can take these nodes. Now if you see, now the intuition behind this problem is all you have to do is just take the star node, fine, and store all its adjacent node. That means all its edges, and its edges are what? 1, 4, 5, and 6. These are its edges, right? Now we'll be writing its corresponding values. If we write the corresponding values, we see 2, then there's 10, then there's minus 10, and then there's minus 20. So these are their corresponding values according to the nodes. Now let's just swap these two guys right here so that it's better. Now why is it better? We'll get to that part as well. So the value to this is 10 and the value to this is 20. And I'm saying for now, or it's already given in the question, that you can take at most two nodes. Fine. Now see, you will always be taking the 4, that is for sure. You'll, because that is your star node, you'll have to take that as your sum, right? Now you can take more two values. What are you going to take? You'll be taking it greedily, right? You'll be taking the largest two values, obviously. That will result in a much greater sum. Why will you even take a smaller value like minus 20 and minus 10? Why are you even going to take this, right? So that is the whole intuition behind this problem. You just make sure that for every node you have all its values, that is all its edges values in the sorted order, and you try to take at most k values from there. You try to add it into your sum, and if you see that okay, I'm getting some greater value, then you are going to take it, otherwise you just exclude it from your sum. Now let's tweak this example a little bit and you'll be good to go for this one. Let's just say all the values here are minus, right? And you still can take two nodes, but are you going to take two nodes? Obviously not. They have said that you can take at most two nodes. Okay, you can take at most two nodes, but you can exclude also. You can say that I will not be taking any nodes. There is an upper bound, but there's no lower bound to this. Let's just forget about every graph that is present here, everything that is present here. Let's just consider 4 is the whole concentrated part. For this we are only concerned about this node 3 right here. So these things are not here. Let's just say fine. So just think about the in your life just 3 exist for just now. Okay, so all you care about is 3 is edges. So if you see that the values are all minus, let's just say every value is in negative, are you going to take these values? Obviously not, because this will result in a much lesser summation, right? So this is not profitable to you. So what are you going to do? It's going to exclude everything. That means you're not going to sum up anything. You're just going to say that okay, I'll go by myself, and the summation that I can give you right now is 4. So that is your answer that can come right here, a possible answer. But obviously this is not the correct question. I've tweaked it a little. So yeah, so for this question the answer output is 16. And also we have to take care of this edge case right here. According to this edge case, they have said that if you see that the edges is empty, all you have to do is return the maximum value from the vals array. Okay, so what do I mean by that? If the edges array is empty, you just return the maximum value from the vals array. Fine. So that is one of the edge cases that you need to take care of that. So that is what we have done. Coming on to the code part. So if the edges array is empty, all you do is return the maximum value from the vals array. If not, what are we going to do? We are just going to store all the adjacency list of each edges. Okay, we're just going to maintain an adjacency list of the edges. Now how do we do that? So all we are going to do is create an array of all the edges. You can use a vector also. I'll just use an adjacency list right here. That is a pretty basic thing that we use in the graph algorithm. You must be knowing this obviously. And if not, you can check any of the graph algorithms. You'll understand this part, why are we using this. Otherwise you can also use an vector or vector, it's perfectly fine. Okay, but here I've just used this. And after this, what are we doing? We are just creating the edges. As they have said that it is an undirected graph, that means if there is an edge between 1 to 2, what are we going to say? That in the adjacency list, what are we going to say? We are going to say 1, you have an edge to 2, and 2, you also have an edge to 1. Okay, so that is why we have to push it back in both the ways. Fine. After that, what are we going to do? All we have to do is just take the values in the sorted manner. That means, remember, while we were pushing everything, that means, let's just say if 1 is there, 1 has an edge to 4 and also 5. And there was an vals array, right? Vals array has been provided to you. And in the adjacency list, what are we going to push back? We are just going to push back all their values. So let's just say this node right here has a value of 10. This node right here has a value of 9. So in the vals array, instead of pushing back all the edges, actually we are just pushing all the values right here. That is what I've written here. Fine. So we are just going to push every value that we are having for each of one's edges. Fine. After that, we have pushed everything. What do we do after that? We are just coming on to the bottom part of our answer, that is the last part. All we need to do is we just iterate from 0 to n. For each guy, I will consider it as a star graph, and I'll try to find the maximum. And after that, how do we do it? You just store it in a temporary array. Fine. If it is empty, no need to do anything. Like if a guy has no edges, are you going to do anything about it? Like let's just say you have a graph of 1 to 2, but there is also a 3, but it does not have any edges. Are you going to do anything about it? Obviously not. So just skip it. Fine. After that, what are we going to do? As discussed, we will be sorting it in the greater order. That means the descending fashion. It will not be 9 to 10, it will be 10 and 9. Why so? Because obviously we will be wanting to take it greedily. As we want the maximum sum, we will obviously want to take the greater values, right? Which will increase our possibility of a maximum answer. So that is why we will be just sorting it in the greater fashion, that means in descending order. And I've initialized the answer variable to just the initial value. That means let's just say if there is a value 1, this is the star node or a star graph, and these are its edges. Let's just say I'm not writing the value now. So for 1, let's just say its vals, or in the vals array, its value was given as 10. So initially I will be having 10, right? After that, what am I having? I am having, let's just say k is equals to 2. So that means I can take 2 more edges. So whatever these guys are having the value as, let's just forget about it right now. All I will do is what? I will initialize my answer to 10 right now. Okay. I will be saying that, okay, for now I have 10. After that, what do? We know that our values have been sorted. Whatever these 4 and 5 will be contributing to me, let's just say it is contributing 1 and this guy is contributing -1. So this thing is already sorted and has been stored in a temp vector right here. Okay. And after that, what are we doing? We are just sorting it, and we have options of how many. Let's just say our k is equals to 2, k is equals to 2, and we can take two values. So now we start on adding everything up. That means we start on adding everything up. So what do? We just take on 10. We'll just say, okay, I have two more values to take. So I'll come on to the first index. I see my summation becomes 11. Well and good. I'll be maintaining a maximum array, and I'll just update the maximum part right now. And I'll decrease the count by 1. Why so? Because I've already taken one value. Now I can only take one more, right? Now, again I'll go on and I'll see, okay, there is a -1. Now the value turns out to be 11 minus 1, which comes back to 10, right? But are we going to take 10? Obviously not. We have got a bigger maximum value. So we'll just take this one. as our overall maximum, and we'll be returning it at the end of the day as maximum only. Fine. Now at any given point, if let's just say the count becomes 0, let's just say you're having a lot of values in your this temporary array, okay, 10, 9, 8, 7, let's just say there are 100 values, but they have said you can take at most 2 element only, okay. So that is why I've put this condition right here, that if the count becomes 0, you just break out of the loop, because you do not have the capacity to take more elements with you. You just have the capacity to take 2. So whenever you are exhausted the capacity, you just break out of the loop, okay. And this is the whole code. I hope you have understood the explanation. And if you have any doubt, you can ask me in the comments, and the code link will be in the description. And also, I've already submitted this code. Okay, just for a quick validation, I'll just run the example test cases right here. But nevertheless, I've already submitted the code, so no need to worry about that. And the code link will be in the description as well. So if you want it, you can just get it from there. And if you did understand the explanation, please